is attractive in nature, that exists between all the heavenly bodies in this, or all the bodies in this universe. So gravitation, it's a force of attraction. You can say that the gravitational force is always attractive in nature. And what is the necessary condition? Which objects can have gravitational forces? Like we have in the electrostatics, we see that the attraction between two objects is due to the charges. Okay. Similarly, in gravitation, we observe that the attraction between two bodies is due to their masses. Okay. So we see here that the gravitational force between two objects is due to the masses, and it's given by the formula F equals G m1 m2 over r square. Also, the gravitational forces, it act along the line joining the two masses. So suppose if you have these two masses and suppose they are separated by a certain distance. So you have these two masses m1 and m2 separated by a certain distance r between them. So also the distance of separations, they are measured from the center. So here the distance of separation will be measured from their centers. And if I measure here, let the distance between them be r. Let this one has the mass m1, this has the mass m2. So the gravitational force between them would be equal to F equals to G m1 m2 over r squared. Now, let's see some characteristics of this. First of all, this force is always attractive in nature. So, if I find out that what are the forces that are experienced by M1. So, M1 will experience an attractive force towards M2. So, M1 will experience a force towards M2 like this, and M2 will experience a force towards M2 like this. M2 will experience a force towards M1. So, can we say that the Newton's third law of motion is applicable here? That every action has equal and opposite reaction? Yes?
Yes, sir.
Yes. So the Newton's laws of motion, Newton's third law of motion is applicable here also. That for every action there is equal and opposite reaction. That the force with which the mass m1 is attracted towards m2, that is the same force with which the mass m2 is attracted towards m1. Here the value of G, which is the universal gravitational constant, is 6.67 times 10 to the power minus 11 Newton meter square kilogram minus 2. Now, there are two things now we are going to discuss. We are about to discuss about the gravitational field, that is acceleration due to gravity, and we will also discuss here gravitational potential. Another point to be discussed is neutral point. Suppose we talk of our solar system and let here be two planets. Let's have these two planets M1 and M2 separated by some distance r. Then if I have a mass m in between them, let's say I have a mass m in between them. Okay, so there is a point between these two masses such that this at that point this mass m will experience a net zero force, because there will be some point at every point this mass m, it is experiencing two forces. It is being attracted by the mass m2 and it is also attracted by the mass m1. So there must be some point where the two forces will be equal to each other, and hence the net force on experienced on this mass would be equal to zero. So the point where the net force experienced by this mass is zero, we call that point as the neutral point. Okay. So this point will be called as the neutral point. Now, what's the use of this neutral point is, suppose if you have okay, suppose if you have a satellite being projected from Earth towards the moon. Okay, so there must be a point between Earth and moon beyond which the gravitational force of the Earth would not be there. Okay, up to a certain point, the gravitational pull of the Earth will be attracting it, and beyond that, after that, if the satellite reaches, so it will be under the gravitational pull of the moon. It will have the gravitational pull of the moon, or it will be under the effect of the gravity of moon. So to project the satellite, we need energy to move it only up to the neutral point, the point up to which the gravitational field is zero, or at which the net force experienced by the mass will be zero. So I hope you have understood this neutral point. There are
Yes, sir.
certain questions which we will encounter about the neutral point also. Now let's see about acceleration due to gravity. We will also see here variation of acceleration due to gravity. So let's see here acceleration due to gravity. Okay. So if you have a mass which is projected to a certain height, or even if it is on the surface of the earth, let's say this be your earth, and we know our earth is too large. So if we have a mass m lying on the surface of the earth, so this mass m will experience, this is the mass m, it will experience a gravitational force towards the center of the earth. Okay. So this mass will experience a gravitational force towards the center of this earth, and this force would be given by g m m over r squared. So here your capital M represents the mass of earth, small m represents this small mass, and r represents the radius of earth. Since the distance between these two masses will we will measure the distance from center to center, and hence the distance between them will be equal to the radius, as this mass has almost negligible mass as compared with the mass of earth, and its size is also negligible as compared with the size of earth. So its size is also negligible as compared with the size of earth. Now the gravitational force between them can be measured by this formula, F equals to g m m over r square. But if I see, so this mass m is experiencing a force given by this expression. And we also know that the force is also given by, force can also be given by ma, mass times acceleration. So if we equate both of these expressions, since whatever force is being experienced by this mass, it should be equal. This gravitational force is creating an acceleration a in this mass. So we can have these two equal, and hence find out the value of acceleration due to gravity, which will be given by gm over r squared. So this is our acceleration due to gravity, which is also represented by the small g. Okay. Now this value, if you calculate by putting the values of g, mass of earth, and radius of earth, if we put the values, we get the approximate value to be 9.8 meter per second square. That is what a acceleration due to gravity is. Now our point starts, will the acceleration due to gravity be same everywhere? So there are three tasks. First of all, if suppose the mass, this small mass, it is raised to a certain height above this, if it is raised to a certain height above the surface of the earth, okay, then what should happen to acceleration due to gravity? Then we will also see, if you bring this mass a little bit deep inside the earth, then what would be the effect of gravity on it? Okay. We will also see the effect of latitude. Okay. So let us see, first of all, if you raise this mass a little bit above the surface of it, so then what will happen? So you have your surface of earth, and above the surface of earth, you raise this mass to a certain height. Let's say you have raised it to a certain height, h. Now I want to find out the value of acceleration due to gravity, as I know that this much height will be equal to the radius. This will be equal to the radius of earth, and height above this. The height above this, that is this height, we will call it as the height up to which the object has been raised. So I have raised this height object to a considerable height. Considerable height means here our height is, it's in, in comparison to r, it's not zero. Okay. So in that case, we can define the gravitational force between the two masses, that is between the earth and this mass, the gravitational force would be given by G m over the distance between them, and now the distance between them becomes r plus h. So you have r plus h whole square. This is the force. The same force would be equal to mass times of acceleration, and hence mass and mass cancel each other. So therefore our acceleration due to gravity would be given by gm over r plus h whole square. This would be the acceleration due to gravity at this point. Now let us find out this, let us represent this at g dash, which is our new gravitational, a new acceleration due to gravity at that point. Okay, now this acceleration due to gravity at that point, it can be, let us try to make it into a proper form or a comparable form. So we can take out r common from this, and the term can be expressed as gm over r squared, and here you have 1 plus h over r whole squared. Any doubts here? How we are getting the expression?
No, sir.
We have just taken out r common from here. Taking out r common will give you r square 1 plus h by r whole square. Now you can write this expression as gm over r squared, and here I can write 1 plus h by r and power as minus 2, negative 2. Since earlier it was in the denominator, so I can write it as negative. Now I know gm by r squared. This gm by r squared is the value of acceleration due to gravity on the surface of Earth. See the previous expression, gm by r squared is the value of acceleration due to gravity on surface of Earth. So I can put this as small g, and hence my term becomes now g dash equals g times of 1 plus h over r power minus 2. So here, this can be broken down with the help of the binomial expression. Now, whenever you have the questions like how much will be the acceleration due to gravity at this height, or if you have a comparison, like we had a question yesterday that at a height of 3,200 kilometer, what would be the acceleration due to gravity? So if you have such questions, so in that questions you have to use it directly. That means in that case you will not use the binomial form. You will use the same expression. You will use the same expression, and uh, in that case you will be getting this expression something like this: g dash over g would be equal to 1 plus h over r power minus 2. This is what you will be getting. And now you can square both the sides. You can square, if you take this square to the other side, so you can find out the value of g dash over g. So the expression can be simplified like this. Now, if you have you had a question regarding h, a comparison between h and d, which says that h and d at a depth at a depth d, which is equal to h, the acceleration due to gravity, expression binomially. And if you expand this binomially, so in the binomial expression we have this formula 1 plus x to the power n should be equal to 1 plus nx, plus it should contain higher powers of x which can be neglected. Since here the value of h is less as compared with r, so h over r, that is x, is less than 1, and hence we can use only this much 1 plus nx. So this expression would become g dash by g equals 1 minus 2h over r. So here we observe that acceleration due to gravity decreases more rapidly as one moves above the surface of the earth. As the height increases, the acceleration due to gravity increases more rapidly, decreases more rapidly. There is a decrease of acceleration due to gravity, since here we have an expression 1 minus something. And as per this expression, we are expecting that at a height if you have 2h equal to r, suppose you have 2h equal to r, so at that point, what should be the acceleration due to gravity? Yes, at that point, what should be the value of
0.
acceleration due to gravity? Shouldn't it be 0?
Yes, sir.
If you put 2h as r, so you get 1 minus r by r, that becomes 1 minus 1, which is 0. So at that point, you will get acceleration due to gravity as 0. So this is not practically possible. The reason being that we have considered here this h over r to be h over r as very much less than 1. If you increase h to a level so that it is comparable with r, so in that cases this formula won't. So this is practically, this one is not possible. But yes, an idea is there that up to this much height, if you are going up to this much height of r by 2, your value of acceleration due to gravity will be very less. Okay. So this was variation of acceleration due to gravity with height. In the similar way, you have an expression that at what height the value of acceleration due to gravity will reduce to 1/16th of its value. Can you do this? Try to do this question. At
Yes,
what
sir.
height? Try out this question. And which formula will you use? First of all, tell me which formula you will use. At what height value of acceleration due to gravity the value of acceleration due to gravity reduces to 1/16th of its value on Earth's surface. Okay. So which formula to be used here? Yes, students, which formula will you use? Want you use
Sir,
this G? Yes, which one? Here you have all the formulas. So which formula will you use? This binomial one or this one?
the one on the top, G dash
Yeah,
by G.
yeah, we will be using this one. So find out this, find out the answer, use this formula. G dash by G equals 1 plus h over r power minus 2. Okay. So see, you have here G dash by G equals 1 plus h by r power h minus 2. So G dash by G, the value is given as 1 by 16. We put here 1 by 16 equal to 1 plus h by r and power minus 2. Now to remove this 2, take this 2 to the other side, or you can say you can apply 1 by 2 power on both the sides, or take under root of 1 by 4 equal 1 plus h by r, and it has the power minus 2 multiplied with 1 by 2. Since under root means power 1 by 2, so multiplied by 1 by 2, you will get the power as minus 1. So hence 1 by 4 equals to 1 plus h by r power minus 1. Now do not reciprocate it directly. Do not just write 1 plus r by h. First take LCM, then reciprocate. And after that, you just need to solve it for the value of h. So this will be equal to 1 by 4 equals r plus h over r power minus 1. And now you reciprocate. So you get 1 by 4 equals r over r plus h. Now cross multiply. You get here r plus 4 equals 4r. So r plus h equals 4r. And hence you get here h equals to 3r. And h will, so at a height, h equal to 3r. If you have height h equal to 3r, so at that height, the value of acceleration due to gravity will reduce to 1/16th of its value. What the answer?
Yes, sir.
Yes. Any doubts?
No, sir.
No. So any such similar question I think you can do. Okay, at what height the value of acceleration due to gravity will become 1/9th of its value? Can you obtain the answer?
Yes, sir.
Okay. So do it quickly. Or you can say, let's say the question be like this. I have a new question here, a little different, but you will be able to, it has to be done according to the same method. So at what height the value of acceleration due to gravity reduces to 36% of its value. 36% of its original value. Okay. So can you try doing this? At what height the
Yes, sir.
value of acceleration due to gravity reduces to 36% of its original value? Okay, so how we will start?
Sir, is the answer h is equal to r by 4?
H is equals to R by 4. Okay, let's check it out. So you have 36%. That means G dash is equal to 36% of G. This means you have G dash over G equals to 36 by 100. Right? So this you take to be equal to 1 plus H over R power minus 2. If you take the square root, you'll get 6 by 10 equal R plus H over R power minus 1. Reciprocate. So 6 by 10 equals to R over R plus H. Now cross multiply. You get 6R plus 6H equals 10R. So you get 6H is equal to 4R, and hence H is equals to 4R over 6. That means 2R by 3. So at a height, H equal to 2R by 3. This is the answer. Where did you go
Okay,
wrong?
sir.
Where did you go wrong?
Sir, I think I did something wrong in calculations.
Okay, you did something wrong, but your logic was correct. Everything was correct here.
Yes, sir.
Maybe I think while reciprocating or somewhere while cross multiplication, you might have gone wrong somewhere. So shall we continue further now? I hope you
Yes,
have
sir.
understood how the acceleration due to gravity varies with height. Okay. Now we'll see how the acceleration due to gravity vary with depth. Okay. So how acceleration due to gravity vary with depth? Oh. Variation of G with depth. So how does acceleration due to gravity vary with depth? See, so again, we take our Earth. And let's say this is our Earth. We are at a certain depth below the surface of Earth. So let's mark the center of Earth. Let this be the center of Earth. And we have made a tunnel. So through the tunnel, we are reaching the center of Earth. Suppose we are at some depth D. We are here at a certain depth D, and we want to find out that what will be our acceleration due to gravity at this specific point at a depth D from the surface of the Earth. So we are still at a distance of r minus d. We are at a distance of r minus d from the center of Earth. Okay. Now, you will say that there is nothing we will directly use at r minus d, but there is a problem, and the problem is of the effective mass. When you reach, as you move down, so the effective mass of Earth decreases. The effective mass of the Earth is the mass of Earth which is enclosed within a sphere of r minus d. Okay. The only mass that is responsible is r minus d, that is the effective mass. So this is the effective mass which is responsible for producing any acceleration in this mass. Okay. The other masses which are above this, they are not responsible. Okay. So to find out this effective mass, let this effective mass be m dash. I'm denoting this effective mass be m dash, where m is the total mass. So we will use the formula of, we'll use the concept of density. We can obtain the density of Earth rho, which will be equal to mass by volume, and volume of Earth is given by 4 by 3 pi r cube. So this is the density of Earth. So then assuming the density of Earth to be uniform, however, it's not actually uniform, but still we assume that the density of Earth is uniform. There is not much variation. So we can find out the mass of Earth which is enclosed within the volume r minus d. So mass of Earth enclosed within the volume r minus d will be given as m dash will be equal to density multiply volume, which is V dash. Let the volume of this sphere be V dash. Okay. So I can write here rho multiply V dash, and V dash is equal to 4 over 3 pi. Now the radius is r minus d whole cube. Okay. So now I can use the formula F equals G mm over r squared to be equal to g equal to mg. Let this be equal to mg. Our target is finding out g. So this m and m will cancel, and let this r be the total r which is left here. So just by putting the values, if I put here value of m, put the value of r, then I will be getting the value of acceleration due to gravity g dash at that point. So I can write here g dash. Let's obtain an expression for g dash here. So I'll be writing g dash equal to g times g over r squared, and r is r minus d whole squared, right, multiplied with density and multiply. This is the new mass or effective mass, which is m dash. So m dash is rho multiply 4 over 3 pi r minus d whole cube. So putting the values, we can simplify the expression as g multiply rho multiply 4 over 3 pi, and multiply we have just remaining with r minus d whole cube. So r minus d only power 1. Since we already have power 2 in the denominator, power 3 in the numerator, so the two powers cancel and we are just left with power 1. Any doubt here? Anything that you have not understood?
No, sir.
No. Now we put the value of density. Density we have obtained here. Putting the value of density, we can get g multiply density, which is 4 by 3. Sorry, m over 4 by 3. Let's put it as m over 4 by 3 pi r cube multiplied with, this is the value that we have, 4 over 3 pi r minus d. So here 4 over 3 pi and 4 over 3 pi cancels. You have just gm over r cube. So take it to the next page. We have gm by r cube multiplied with r minus d as g dash. Okay. So I can write this r cube something like this. I can write it as gm over r squared multiplied with r, and here in the numerator we have r minus d. Can you write like this? Just I have expressed this r cube as r square multiply r. Okay.
Yes, sir.
Take this r within the bracket and you get here gm over r squared. What's this value? Gm over r squared?
G.
Yes, this is the value of g on the surface of earth. So we can put here g, and here we'll get as 1 minus d by r equals g dash. So we get 1 minus d by r equal to g dash by g. So what should be the value of acceleration due to gravity at the center of earth?
Zero.
0. At the center of the earth, the acceleration due to gravity reduces to 0. Okay. Now here, what does this all concept mean? That if you are moving down if you open a through and through tunnel, okay, if you open up a through and through tunnel through the earth, let's make a through and through tunnel. We had seen a question of through and through tunnel also yesterday. So here I'm making a tunnel which is through and through so that you can pass through it. And if you drop any object through its center, so let this be the center, and I drop any object from here. So on this surface, it will have its value of acceleration due to gravity as g, which is maximum. And as the ball moves down, the value of acceleration due to gravity decreases. Okay. But along with it, the speed also increases. The speed, since there is acceleration, so the speed will increase. And when this ball reaches the center, so at the center, its acceleration due to gravity g dash will be zero, but it will have a certain velocity. Its velocity will not be zero. Velocity will be non-zero because it was continuously accelerating towards the center. Its speed was increasing continuously. So at the center, it will have a certain maximum speed. And now if it moves away from the center, if the object moves away from the center, it goes away. So suppose the ball is here. I have the ball here or the object here. So in which direction will the acceleration due to gravity act at this point? If I am at the bottom point, so where should the acceleration due to gravity act? In which direction?
Towards the center.
Towards the center. Now here the acceleration due to gravity will act towards the center, and hence here the object will experience acceleration due to gravity towards the center, but due to its speed it will continue to move in the upward direction. And when it reaches the top, if it reaches the top over here, so its acceleration due to gravity will become maximum. Whatever kinetic energy it had attained at the center will be converted to potential energy at the surface, and now again it will come down towards the center of. So any object which is made to fall in this through and through tunnel of the earth, so that object will experience SHM or simple harmonic motion. So yesterday we had done this question. We had also find out the time period or the time period that it will take to complete one oscillation, and we had got nearly around 84 minutes as the answer. So 1 hour 24 minutes. 24 or 12 minutes something we had 24 minutes. Okay. So understood these concepts of through and through tunnel, the variation of acceleration due to gravity with depth, and the variation of acceleration due to gravity through height.
Yes, sir.
Okay. So in the next class, we will be continuing with gravitation. We will do a few more topics like the gravitational potential. And if you can read that gravitational potential before only, so we can do a number of questions. We can start with questions from tomorrow or day after tomorrow. Still.
Okay, sir.
Okay. So bye everyone. Bye both of you.
Thank you, sir.
Okay. So how was the class?
Good, sir.
Okay, bye.